A warm welcome to one and all. Myself Preeti, Assistant Professor, working in Dr. NGP Institute of Technology, Department of Electronics and Communication Engineering. I would like to share the presentation with regarding to the subject Cryptography and Network Security. This is an elective subject offered by the third year students of ECE department in Regulation 2017. And I'm going to start off with Unit 5, that is Security Practice and System Security. In this video, I'm going to cover the system security part, which covers the intruders, malicious softwares, viruses, and firewalls. So starting up with the firewall. What is a firewall? So now everyone wants to be on the internet and to interconnect the networks. So we have to know what particular authentication entity is going to protect us from the other untrusted networks. Such kind of entity is nothing but a firewall. A firewall forms a barrier through which the traffic going in each direction must pass through it and have to get the proper authentication. It provides a perimeter defense for the system. So now what is a firewall? A firewall is nothing but a choke point for controlling and monitoring the whole network. The firewalls can be effective means of protecting a local system or network of systems from a network-based security threats, while at the same time it affords access to the outside world via wide area networks and the internets. Normally, centralized data processing systems will have central mainframe supporting firewalls that could impose restrictions on the network services. Restrictions in the sense, without any specific authorization certificates or authorization, no other person can enter into the particular network and access the data. It can also implement alarms for the abnormal behavior of the particular network. That is, when a person enters into a network without proper authentication or authorization, then an alarm can be initiated to give a abnormal behavioring of the network to the particular administrator. Now, even though the firewall has many advantages, it do have some limitations also. That is, it cannot protect from attacks bypassing it. So all the firewalls cannot be very strong enough to protect from every unauthorized user. Some, for example, sneakernet, utility modems, your trusted organizations, your services, again, it will bypass the network firewall and go into the network access. And also, it cannot protect against the internal threats, that is disgruntled or colluding employees. Cannot protect against access via wireless LAN if improperly secured against the external use. And again, cannot protect against malware imported via laptop or PDA or storage infected outside. Malware in the sense it could be a virus, a worm, or whatever it is. Now, coming on to the types of firewalls. So before going into the types of firewalls, I want to give you the characteristics or design goals of a firewall. So what could be the design goal of a firewall? All the traffic from inside to outside and vice versa must pass through the firewall. This is the main motto of the firewall. This is achieved by physically blocking all access to the local network except via the firewall. Various configurations are possible also. Only authorized traffic as defined by the local security policy will be allowed to pass. Various types of firewalls are used which implement various types of security policies to implement the highly authorized and secure network. The firewall itself is an immune to penetration. This implies that use of trusted system with secure operating systems. Now we have some preliminary service controls, that is service control, direction control, user control, and behavior control. All these controls will tell you how the particular firewall works, if it comes with service or if it comes with direction, whether it is a unidirectional firewall or a bidirectional firewall. Even if the employee is working inside a company, should have some accessing authorization to access the particular network and so on. Next comes the types of firewalls. We have three different types of firewalls. One is packet filtering router, and next one is application level gateway, and next one is the circuit level gateway. Now first we are going to see with the packet filters. The packet filter routing applies set of rules to each incoming and outgoing IP packet and then forwards or discards the packet. Here, the router is typically configured to filter packets going in both the directions, that is from and to the internal network. The filtering rules are based on information contained in a network packet. This is mainly very simplest and fastest firewall component. It is the foundation of any it could be made as a foundation of any firewall system. And its main motto of this particular packet filter firewall is to examine each IP packet and allow and permit or deny according to the rules that is being framed for the particular network. So what kind of information that could be contained in a network packet? So for example, a network packet could consist of source IP address, that is IP address of the system that originated in the IP packet, and the destination IP address, that is the receiver, the IP address of the system which receives the particular packet, the source and the destination transport level address, that is transport port number, which defines the applications such as SNMP and Telnet. Then next is IP protocol field, defines the transport protocol which is used in the particular transportation. And next is interface, that is for a router with 3 or more ports, which interface with the router the packet came from, or which interface with the router the packet is destined for. So the packet filter is typically set up as list of rules based on matches to the fields in the IP or TCP header such that it reaches the correct person, and for reaching the correct person the particular authenticity is given to the particular packet that has been reaching the firewall. So it hence restricts access to these services, that is for ports. Every port differs, it has to reframe its rules and regulations. If there's a match to one of the rules, that rule is invoked to determine whether to forward or discard the packet. And in the same way, if there is no match to any rule, then a default action is taken. So there are two default policies that are possible. First one is default discard, second one is default forward. So discard is nothing but permission is prohibited, and if it is forwarded, then permission is given to forward the packet. Now you can see here a simple network where a security perimeter is being established for a private network. So any data that is coming in from the internet should cross the packet filter router, which has a strong firewall in it installed, and that has to allow or give the authentication in order to enter into the private network. For example, in our college, even though we use internets, if we want to access the college internet or college Wi-Fi connection, we have to have a proper password, proper account created. So what we will do, we will go take our laptops and we will share the MAC ID with the system administrator, where the system administrator will add the MAC address to the IP network such that we can access anywhere our college Wi-Fi. This is with the firewalls. The firewall installed in the college Wi-Fi network should accept our request for connecting into it. That is provided by the system administrator. Next, here you can see some packet filtering examples. That is where we have to block or where we have to allow, and what is a particular command that could be given by the particular networks. So in first one, actually you can see an inbound mail is allowed but only to a gateway host. However, the packets from particular external host SPI got are blocked because the host has a history of sending massive files in email messages. So when the particular person is trying to send bulk mails, so that could corrupt our mail system. So for that purpose, the particular administrator has blocked the mails from the external hosts SPI GOT. So hence only the inbound mail is allowed till the gateway host. And next is for the B option or the B example, this is an explicit statement of the default policy. So all rule setup include this rule implicitly as the last rule. Here, that anything comes inside will be blocked according to the default rule. Next one is C. Here, the allowed rule is being implemented. That is, any data which comes inside will be allowed with such that the connection to your SMTP port is enabled. Next is D. The D example tells us that this rule sets achieves The intended result it was not achieved in C actually. The rule takes advantage of feature of TCP connections also. In C, where we had only SMTP connections, only the SMTP ports was enabled, and any data coming through that port will be allowed for the access. But that is not the case in all the data files that has been transmitted from one end to the other end. So when we come for the other, when we use the other ports also, we have to have the access. So the D is an example for that one. Next is last example is nothing but this is one approach to handle FTP connections. With FTP, two TCP connections are used, a control connection to set up the file transfer and data connection for the actual file transfer, and the data connection uses a different port number that is dynamically assigned for the transfer. Most servers and hence most attack targets live on low numbered ports. Most outgoing calls tend to use a high numbered port, typically above 1023. Thus, this rule set allows such type of networks that such that it uses the normal calls and also the any other special calls that could access a port number above 1024. So this is up with the packet filters. Now what are the attacks on the packet filters? Because each firewall have some advantages and disadvantages. So what are all the attacks that are possible on the packet filters? The first one is IP address spoofing. The intruder transmits a packet from outside with a source IP address field containing an address of an internal host. The attacker hopes that the use of spoofed address will allow penetration of the systems that employ simple source address security in which packets from specific trusted internal host are accepted. The countermeasure is to discard the packets with an inside source address if the packet arrives on an external interface. So the next type of attack is source routing attack, where the source station will have a specific route to reach the destination. So the attacker, what he will do is he will set a route that other than the default route. So when the particular receiver identifies that this route is not the correct route which was set by the source for to the destination, then it will block all the source routed packets. The next one is tiny fragment attacks. That is, the attacker, what he will do is he will collect all the data, he will fragment. If the particular data is being fragmented into 10 packets by the source, he will fragment it into 20 packets and he will force the TCP header to change the number of packets also. So when this particular 20 packets, when this particular header reaches the destination, that is a firewall in front of the destination, so when it checks for the particular fragment details, a new rule could be enforced such that the fragment, if tiny fragment attack can be defeated by enforcing a rule that the first fragment of the packet must contain a predefined minimum amount of transport header. If the first fragment is rejected, the filter can remember the packet and discard all the subsequent fragments. So this is up with the packet filters. Next type of filters is nothing but your stateful packet filters. So stateful packet filters is nothing but it's an inspection firewall. It's a traditional packet filter that makes filtering decision on an individual packet basis and does not take it into consideration any higher layer context. So to understand what is meant by the context and why a traditional packet filter is limited with regard to the context, a little more in-depth knowledge should be needed. These most standardized applications run on top of the TCP follow a client-server model. For example, SMTP email is transmitted from a client system to a server system. The client system generates a new email messages typically from the user input. The server system accepts the incoming email messages and places them in the appropriate user mailboxes. So the SMTP here operates by setting up a TCP connection between a client and the server, in which the TCP server port number which is identifies the SMTP server application is 25. So only if the 25 server port is being used over here, the SMTP application could be used for the TCP connection. The TCP port number of SMTP client is the number between 1024 to 65535 that is generated by the SMTP client. So this could be a good example for a stateful packet filters. So, a stateful inspection packet filter tightens up the rules for TCP traffic by creating a directory of outbound TCP connections. So, there's an entry for each currently established connection. So, a packet filter will now allow incoming traffic to high number ports only for those packets that fit the profile of one of the entries in this directory. Next, we are going to see about the application level gateway. So, here in application level gateway, it is also called as a proxy server and acts as a relay of application level traffic. So here in this picture, you could see we have two types of TCP connections. There is the user contacts the gateway using a TCP IP application such as Telnet or FTP. And the gateway asks the user for the name of the remote host to be accessed. When the user responds and provides a valid user ID and authentication information, the gateway contacts the application on the remote host and relays the TCP segments containing the application data between the two endpoints. If the gateway does not implement such proxy code for a specific application, the service is not supported and cannot be forwarded across the firewall. Further, the gateway can be configured to support only specific features of an application that the network administrator considers as acceptable while denying all other features. So, an application level gateway tends to be more secure than the packet filters when comparing. Next, we are going to see about the circuit level gateways. Here, we have to rely on two TCP connections. This can be a standalone system or it can be a specialized function performed by an application level gateway for certain applications. A circuit level gateway does not permit an end-to-end TCP connection. Rather, the gateway sets up two TCP connections, one between itself and the TCP user on an inner host, and the other one between itself and the TCP user on an outside host. So there are two TCP connections here established. So once the two connections are established, the gateway typically relays TCP segments from one connection to the other without examining the contents. So the security function consists of determining which connections will be allowed and which connections will not be allowed. A typical use of circuit level gateway is a situation in which the system administrator trusts the internal users. So where whatever information which is shared by the internal user is highly trusted information for the particular gateway. So a gateway can be configured to support application level or proxy service on inbound connections and circuit level functions for the outbound connections. You can change the configurations according to your usage and the network specifications. So here we have a term called SOCs. So usually a circuit level gateway implementation is a SOCs package that could be considered as an example. So what is a SOC? SOC is nothing but it is type of gateway, the circuit level gateway that is implemented with an RFC 1928. It is defined as RFC 1928. The protocol described here is actually designed to provide a framework for client-server applications in both the TCP and UDP domains to conveniently and securely use the services of a network firewall. The protocol is conceptually a shim layer between the application layer and the transport layer, and as such does not provide network layer gateway services such as forwarding the packets of the ICMP messages. This is up with the types or categorization of the firewalls. Next, we are going to see about an important term called Bastion Host. So, a Bastion host is a system identified by the firewall administrator as a crucial and critical strong point in the network security. It actually acts as a platform for an application level or circuit level gateway. The common characteristics of Bastion host is high actually. Few could be noted such as the Bastion host hardware platform executes a secure version of its operating system, making it as a highly trusted system. So it is very potentially exposed to hostile equipments and elements only. So the Bastion system host may require additional authentication before a user is allowed access to the proxy services. So each proxy is configured to support only a subset of the standard application command set. Each proxy maintains detailed audit information by logging all the traffic, each connection, and the duration of each connection. The audit logs, everything will be audited, and after auditing each and every small information, the software packages will be checked whether this particular detail has could be included, or it could be allowed for entering into the particular network, and then only the Bastion network enters it. So it may be a trusted to enforce policy of trusted separation between these net connections. So next we are going to see about the different types of configurations in the firewalls. So we have normally three different configurations. First one is screened host firewall system, that is single homed base station, Bastion host. And next is screened host firewall system, dual home Bastion host. And the third one is screened subnet firewall system. So coming on for the first one, you can see the first picture, that is a screened host firewall system. Here you can see two different types of systems implemented in the same network. The first one is packet filter router, and the next one is Bastion host. Here the main configuration is such that for traffic from the internet, only IP packets destined for the Bastion host are allowed in. So any packet that could reach the first destination should be Bastion host. And for the traffic from the internal network, only IP packets from the Bastion host are allowed outside. So the only point of contact between the internet and the particular private network host is nothing but the Bastion host, not the direct private network hosts that are sitting inside the network. So it performs authentication, and the proxy functions vary in a higher level. It creates a greater security than simply implementing a packet filter router or an application level gateway alone. So the next one we are going to see about is screened host firewall, dual homed Bastion host. So here what is the difference in the sense? In single home configuration, if the packet filtering router is completely compromised, traffic could flow directly through the router between the internet and the other host on the private network. But here in dual home Bastion configuration, physically prevents such a security breach. The advantages of dual layers of security that were present in the previous configuration are present here as well. Again, an information server or the other host can be allowed direct communication with the router if this is in accord with the security policy. Next, the third one is nothing but your screened subnet firewall. So screened subnet firewall is nothing but this is the configuration, and it is most secure of those we have considered. With the previous compared to the previous both configuration system, this configuration is highly secure, and it consists of two packet filtering routers, one between the Bastion host and the internet, and another one between the Bastion host and the internal network. So again, the authentication has been tightened such that no untrusted packets could enter into the private network. This configuration creates an isolated subnetwork which may consist of simply the Bastion host, but may also include one or more information servers and modems for dial-in capability. Typically both the internet and the internal network have access to the host on screen subnet, but traffic across the screen subnet is blocked. This configuration is actually very advantageous, and it has three levels of defense to the threat intruders. Intruders are nothing but unwanted users or unauthorized users who would like to enter into the private network. The outside routers advertises only the existence of the screen subnet to the internet. Therefore, the internal network is invisible to the internet. So always this private network, which is being seen in the other end of the configuration, is hidden from the point of the internet. So internet can view the Bastion host only. So the communication will happen between the internet and the Bastion host, and only if the Bastion host allows, the data will cross the private network, cross and reach the private network. The second part of the particular presentation is nothing but virtual private networks. You have virtual private networks where an IP security mechanism has been implemented such that a new header and the encapsulation and payload mechanism is being used over here to highly enhance the firewall configuration networks. So now coming on to the summary of firewall locations and topologies, we have seen so many different types of firewalls and different types of configurations on which the firewall works in. So this is up with the firewall topic. Thank you.